For decades, humanity has dreamed of controlling the very fire that powers the stars. A fire that doesn't pollute, doesn't run out, and could, in theory, power civilizations for millennia. And now, in a vast laboratory in India, buried under layers of bureaucracy and ambition, that dream is inching closer to reality. But beneath the glow of fusion promises lies a darker layer, because every step forward in harnessing nuclear energy, no matter how peaceful, casts a shadow shaped like a missile. This is the story of India's Tokamak fusion reactor, a story of plasma and power, science and sovereignty, and a subtle dance between energy and arms. Let's start at the core. Fusion is the process that powers the sun. Unlike fission, which splits atoms and leaves behind dangerous waste, fusion joins light atomic nuclei, usually hydrogen isotopes, to form helium, releasing enormous amounts of energy. It's clean, it's safe, and it's incredibly hard to do. Because to fuse nuclei, you need to recreate the sun's conditions, temperatures over 100 million degrees Celsius, and pressures no material on Earth can withstand. So how do we do it? The answer is the Tokamak. Invented in the Soviet Union in the 1950s, the Tokamak is a donut-shaped chamber where magnetic fields imprison a super-hot plasma, a seething charged soup of ions and electrons, until conditions are right for fusion. And India has one. In fact, it has several. But one stands out. Welcome to Institute for Plasma Research, IPR, in Gandhinagar, Gujarat. Here, two of India's most ambitious fusion projects live. ITER, the country's first indigenously built tokamak, and SST-1, the steady-state superconducting tokamak. ITER was India's first step into the fusion arena. Operational since the 1980s, it was small, experimental, but bold. SST-1, however, was a different beast. Started in the early 2000s, SST-1 aimed to go steady-state, meaning it could sustain plasma for longer durations using superconducting magnets, a major technological leap forward. It wasn't just a test reactor, it was a statement. India is serious about fusion. SST-1 has faced delays, redesigns, and funding hiccups. But by 2017, it began producing real plasma discharges, pushing India into the elite club of nations with operational superconducting tokamaks. It's not ITER scale yet, but SST-1 has contributed directly to India's participation in the International Thermonuclear Experimental Reactor, ITER, in France, where India is a full member and supplier of critical components like cryostats and cooling systems. India isn't just watching the fusion race, it's running it. So why invest in fusion? 3 big reasons. 1. Energy security. India's energy demand is expected to double by 2040. Fossil fuels can't meet that without choking the planet. Solar and wind help, but they're intermittent. Fusion offers continuous baseload power. 2. Scientific prestige. Fusion isn't just power, it's prestige. Building and operating tokamaks puts India in the same league as scientific superpowers. It's soft power, earned through plasma physics. 3. Strategic leverage. And here's where the story gets interesting and darker. Fusion and fission are different, yes, but not unrelated. To understand how India's peaceful fusion program intersects with its nuclear weapons capability, we need to rewind history. India exploded its first nuclear device in 1974. It was called Smiling Buddha, a peaceful nuclear explosion. Then again, in 1998, with the Pokhran II tests, India declared itself a full nuclear weapons state. Unlike fusion energy, which aims to contain fusion reactions for power, thermonuclear weapons use fusion unleashed. a deuterium-tritium reaction, triggered by a fission bomb to achieve massively destructive yields. India claims to have developed thermonuclear capabilities, but many experts believe its hydrogen bomb tests in 1998 were only partially successful. Still, the knowledge needed to handle plasma, magnetic confinement, and tritium breeding, skills honed in civilian fusion research, can overlap with military applications. Let's be clear, India's Tokamak projects are officially peaceful, they're transparent, they're shared with ITER partners. There's no evidence they're being used for weapons. But the line between peaceful nuclear technology and military use is never as clear as governments like to claim, especially when tritium is involved. Tritium is a radioactive isotope of hydrogen, used in both fusion reactors and hydrogen bombs, and it's rare. In nature, almost non-existent. That's why fusion reactors, like SST-1 and future demo plants, must learn to breed tritium inside the reactor using lithium blankets that capture neutrons and produce tritium. It's elegant engineering, but the moment you can produce tritium at scale, the strategic implications shift. Because tritium is a booster in nuclear weapons, increasing efficiency and yield, and tritium decays fast. Its half-life is just over 12 years. So nations need a steady supply to maintain modern nuclear arsenals. In theory, a large-scale fusion program could help maintain or expand a tritium stockpile, even if no one says it out loud. In geopolitics, perception is power. Even if India's Tokamaks are purely civilian, their existence affects strategic calculations in neighbouring countries, especially Pakistan and China. Pakistan has long suspected that India's nuclear infrastructure hides more than it shows. China, while ahead in fusion and fission, watches India's scientific ambitions warily. Fusion programs provide scientific cover, a reason to develop advanced materials, cryogenics, and plasma science without declaring any military intent. Even if no tritium is diverted, the capability exists. This is called latent proliferation, a nation developing all the expertise and infrastructure needed to go nuclear, or thermonuclear, fast. Without violating treaties or norms, India isn't alone. Japan, South Korea, Germany all have fusion programs and nuclear latency, but India's status as a nuclear weapons state outside the Nuclear Non-Proliferation Treaty, NPT, puts it in a unique and controversial spotlight. Let's return to ITER. India is one of 7 main partners, alongside the EU, US, Russia, China, Japan, and South Korea. India's contribution is substantial. Over 9% of the budget, including critical components like the world's largest cryostat. This partnership gives India access to global fusion research and cutting-edge technology. But it also brings scrutiny, because while ITER is peaceful, the dual-use nature of many technologies, superconducting magnets, high-temperature materials, neutron shielding, is hard to ignore. India has agreed to safeguards, but as a non-NPT nuclear weapons state, its commitment to non-proliferation is still questioned by some. It's a tightrope. Fusion collaboration helps India rise as a scientific power, but it also raises the stakes. Where does this all lead? India is already planning its next-generation Tokamak, called DEMO, short for Demonstration Power Plant. This reactor would go beyond SST-1, aiming to produce real net energy from fusion reactions. Not just experiments, real power. If successful, it could revolutionize India's energy landscape, providing carbon-free, abundant electricity. But the deeper India goes into fusion research, the more it needs to grapple with the ethical shadows. Because science is not immune to geopolitics. The same knowledge that lights homes can vaporize cities. The challenge is not whether India can build a fusion reactor or even a better bomb. It's whether it can do the former without sliding into the logic of the latter. In the heart of Gujarat, under coils of superconducting magnets and walls of liquid helium, India's Tokamak hums with plasma and promise. It is a symbol of national pride, of human ingenuity, of hope for a planet in crisis. But like all nuclear dreams, it casts a double shadow, one of power and one of peril. The question is not just what India will do with its fusion fire, it's what all of us will choose to do when science and security meet at the edge of the atom.